So far, we've looked at y equals x, which is quite easy. It's just a straight line. And then we looked at y equals x squared, which is this, this. Okay, and then we looked at y equals x to the power 3, and it's a lot steeper than x squared. Okay, so it's something like this. Oh, something like this. Yeah. And then in this video we are going to look at y equals x to the power of 4. So what is this graph? What would this graph look like? Okay, so let's try to investigate here. So we are trying to investigate y equals x to the power of 4. Now let's put 0 into the x. So if you put 0 into the x, it would be 0 times 0 times 0. Well, overall it would be 0. Okay, and if you put 1 into the x, 1 times 1 times 1 times 1, it would be 1. Now on this scale here, this is the y here. On this scale here, from here to here is 1000. So 1 is somewhere near the bottom somewhere here. Okay, it just doesn't show up. If from here to here is 1000. Okay, so the number 1 would be right at the bottom somewhere. Now when it comes to 2 times 2 times 2 times 2, well that's like saying 4 times 4, which is 16. Now 16 is still it's still right at the bottom somewhere. You can't even see it on this scale. Now 3, well it would be 3 times 3 times 3 times 3, which is like saying 9 times 9, which is 81. Now 81 is probably, it's still really small, but it's still higher than the previous 3. Okay, now we've got to do 4 times 4 times 4 4 times 4. That's just like saying 16 times 16. So what's 16 times 16? Clear this. 16 times 16 equals 256. So let's say, well, if one block is 1000, then this would be 500. This would be 250. So hang on. So let's try and plot that. 250. I'm going to say it's roughly 250. So that's a quarter of a square way down, if you like. So it would be somewhere here. Okay, and now if you I think I better clear this. Hang on. Okay, now if you look at 5, so that would be 5 times 5 times 5 times 5. I'm just going to say it's 25 times 25. So what's 25 times 25? Clear it. 25 times 25 equals 625. So 625 is probably I'm just going to guess it's somewhere here. Okay, and now when it comes to 6, so 6 times 6, I'm just going to say it's 35. 36 times 36. Okay, because you've got this. So this is 36, this is 36. So it's 36 times 36. Hang on, clear this. 36 times 36 equals. Now it's jumping up quite a lot. 1,200. I'm just going to say, inside my mind, I'm going to think 1,250. 1,250, so somewhere around here. Okay. Now it's 7. So it's 7 times 7 times 7 times 7. I'm just going to say 49 times 49. So clear this. 49 times 49 equals 2,000. I'm just going to say, inside my mind, 2,500. 2,000 is here. 500, slightly lower than 500 there, around here. And now it's 8. So it's like me saying 64 times 64. Okay, so calculator, clear. 64 times 64 equals 4,000. I'm just going to say around about 4,000. Okay, so it climbs up like this. I'm just going to jump to the 10. So that would be like me saying 100 times 100. So that's 1, 2, 3, 4 zeros. So that's 10,000. Um, uh, yeah, that's 10,000. You see, it jumps off our scale here. Well, actually, 9,000's here, 10,000's here. So it's just about here. Okay. Oh, let's put in the 9 as well. So that's like me saying 81 times 81. Hang on, let me just quickly do the 9 as well. So 81, clear this. 81 times 81 equals. I'm just going to say 6,500. 6,000's here, 500 is here. So it's going to be somewhere around here. Now, the thing is, this thing here is symmetrical. So, because if you think about it, let's just look at 4 and negative 4. Okay, 4 and negative 4. Over here is 4 times 4 times 4 times 4. Now, if you look at negative 4, hang on, let me clear this up. Hang on. Now, if you look at negative 4 right here, well, negative 4 will be negative 4 times negative 4 times negative 4 times negative 4. Now, if you merge these two together, it becomes 16, positive 16. And merge these two together, it becomes positive 16. Now, if you do these two, it's still 16. This here is 16. My point is that even though you've got minuses, they cancel each other out, because a minus times a minus would be positive. Here you've got a minus times a negative times a negative. My point is that these two, they're symmetrical. So you doing the 4 here is the same as you doing the negative 4. So here it should be the same height. So my point is that this graph will be like a U shape. Okay. So y to the power y equals x to the power 4. It will look like a U shape. An ugly U shape. Hang on. Let me try and give you a nice looking U shape. So it's supposed to be symmetrical. So when you get to here, it will be symmetrical. So the graph of y equals x to the power 4, it will look like a U shape like this. And then you could argue that, oh, isn't that the same as y equals x squared? Well, y equals x squared. Let's look at this here. Now let's don't forget. I'm just ignoring the negative side because it would be symmetrical. Okay, it would be symmetrical. It would be the same. So here now look at the y equals y equals x squared. Now, when y equals x squared, y equals x squared will be here. 2 will be 4. 3 will be 9. On the here, my point is that 6 will be 36. It's still at the bottom. 5 here will be 25. It's still hovering above the 0 on this scale here. So 7 times 7, it will be 49. It's still 8 times 8 will be 64. It's still hovering there. 9 times 9 is 81. It's still down here. 10 times 10 is 100. It's still down here. And so on. 144 is still down here. My point is on this scale here, x to the power x squared will look something like this. It's still a U shape, but on this scale, my point here is that if you have this, if you try and draw this line here, let's say hang on, let's clear this. If you try and draw y equals x to the power 4, it will look like a U shape. Okay, just like x squared. But if you superimpose x squared on here, it will look something like this. It's still a U shape, but it's just a lot shallower, a lot shallower. Okay, now don't forget, this is y equals x squared. Don't forget y equals x to the power 3. Even though it's like this thing here, but it climbs. You know y equals x to the power 3 climbs a lot faster than x squared. But the thing is, x to the power 4 is a lot faster than x to the power 3. So, well, anyway, so when people sketch y equals x to the power 4, x to the power 4, it looks like x squared because we haven't got the scales on there. So x to the power 4 and then x squared here, y equals x squared. They look the same. They look the same, but that's because the scale is not on there. If you try and superimpose x squared on this graph, it will look something like this, really shallow. Okay, just bear that in mind. Okay.